hello. This is the re-record of our last lecture right before spring break. Just because the file didn't really work out, so I just decided to redo the lecture anyway. So here it is. Basically the same lecture we had in class. For those who missed it or those who want to review, P.S. I moved the assignment, that first Max assignment that was due, I moved it back to the Friday. Forward, I mean. I moved it forward to the Friday. So it's not due on the Tuesday. I don't want anyone panicking or worrying about that. Anyway, where we started in our class, and I'll just begin there, was we were talking about this concept of affordances. Do you remember the first class? We were talking about having a concept of time. And how a concept of time and a way to measure time is itself a technology. And it's one that so-called musical technologies are dependent upon. Along that same idea with time, we have affordances that seem to designate our organization of time. So you think about the affordances given to you in MuseScore. And MuseScore wants you to create, generally, scores that are fitting into a largely Western idea. There's some exceptions and some plugins that kind of break out of that a little bit, but largely within a Western paradigm of how music is supposed to be notated, represented, and then interpreted. It's a little more challenging to create kind of free-form notation and graphical notation in MuseScore. It's not designed for that. That's not one of its affordances. So it makes certain things easy, like making an orchestra score. Yeah, for sure. But then if you want to represent improvisation, you need to take some extra steps and things in the app. So that's my idea about like affordances and deficits. Not my own personal idea. I borrowed it from James Gibson. And I've put reading from James Gibson's book on the class website, the particular chapter that has to deal with affordances. And it's not super academic. I recommend strongly you go and give it a read. I think you'll find it very interesting. One of the things I like about Max is that by making a Max patch, we're working with a different set of affordances. Is it a completely blank canvas? Yes. We're working mostly with actually entirely, in this case, in our class, entirely with vanilla Max objects that are just that have become part of the software over time. And so, as a result, we're dealing with those affordances. But one of the things that's really great about Max is our ability to chain objects together, which we're going to talk about in a second. Okay, so this is my Max patch window. Mine has a black background just because of color settings I made. You can change those if you go up to your Max preferences, and you can change some of these things. I don't know if it matters to you, but you can make it any which way you want to. I'm gonna go to not something so dark. No. This will be okay. I want to make sure everything is still legible and easy for you to read if you're watching this, but also not going to hurt your eyes or something. Okay, so you can, on any of these computers in the lab or on your personal device, you can change the color. It's not going to affect anything. Again, that was Max preferences. Anyway, so this is our patcher, and that's a fancy word for our user interface that is going to represent kind of our coding and development space. This is, in its own way, a particular type of coding. We tend to think of just like streams of text going, but this is in its own way operating quite like that. How do we start doing this? Well, I got to point out a couple things. So in the patcher here, one of the most important things you need to know right off the bat is this locked versus unlocked. And what I'm doing is I'm clicking on the little padlock down here. Now, when the patcher is locked, we're going to see later, we can interact with any object we have in the patcher. When the patcher is unlocked, we can modify those things. I'm going to say that again. When the patcher's locked, you can interact with things. And I'll give you a demonstration in a second. And when it's unlocked, you can modify things. So, in our process here, we need to create some objects. Now, our first demonstration in class was to make a metronome. Along the way, I want to introduce you to some of these objects. So I'm going to be using some hotkeys and not just clicking. I want to say that any object I'm mentioning can be found up here. And there's several types of objects. There are just these objects, like a text box opens. Let me zoom in. Like a text box will open. Or a message box, which looks different from the object. Let me leave these up here so we can kind of see the difference. And there's a comment box. There's a toggle. I'm just clicking on these buttons up here. Buttons, all kinds of buttons. We won't need all of them in our class, right? And then sliders and even more stuff. I would recommend that you don't play with the format right now. You don't need to. You don't need to change the colors of things. It's fine. You can change the theme of the thing, but just for now, it's okay. You can leave that one alone. So by and large, these are the objects that we're going to need. So I'm going to delete these. By the way, I'm just clicking and dragging like I would on any device. Do that. Let's make a toggle. So you can either click up here. And notice that when I roll my mouse over it, it tells me toggle T. That's the hotkey. I can just press T on the keyboard. Over time, this is a big time saver if you're making a lot of these things, which we'll come to see. So toggle, and I'm just going to choose arbitrarily just to make it bigger, just so we can see it for our video. Now, back to the idea of locking or unlocking the patcher. If I lock it, I can now press the toggle. And when it's lit, it's on. And when it's unlit, it's off. And I'm literally just clicking with my mouse. If the patch is unlocked, I won't have the ability to do that. Instead, it thinks I want to move it somewhere and not interact with it. Notice this too. Mac's objects have inlets, that's this guy on top, and outlets. Inlets are always on the top of the object. Inlets are always on the top of the object, and outlets are always on the bottom of the object. Always. It will not change. And the inlets and outlets will do different things. If you roll your mouse over them, your cursor, you will see what it does. So this one says, int sets toggle bang reverses it. I'll explain what that means in a second. Down here, this one says output 1 or 0 when toggle is set. So a lot of Macs is operating, because we're thinking about it as a coding environment. It's operating in computer world, and remember that 0 is off. It's nothing. 1 means on, go. So when this is on, it's sending a signal that says do something. If you want to be a cool Mac's cat like me, you can hit Command on your Mac keyboard or a CMD on the school keyboards. Command and then click anywhere that's not an object. It'll lock or unlock the patcher. So if you see me doing that, I'm not going down here. It takes too long. I'm holding Command and clicking. Anyway, so let's make a metronome. We have a thing that turns something on. We're going to make a bang. Press B. You'll also find them here, right? Now here they're calling it a button. I grew up with Macs saying bang. It's a bang. Anyway, bang is also like particular to Macs. Like if you talk to other people who are like written out coders, they won't know what you mean by bang. That's a very particular Macs kind of thing. Okay, so this is a bang. I'm just gonna make it bigger, make it like the size of just so you can see it more easily. And great. Okay, cool. That's neat. Now I need to make a metronome because I just want this light to blink at a steady pace. So I'm going to go up here and create an object. I could also just hit N on my keyboard. And then my little object box comes up with a text prompt. See the guy blinking there? Yeah. Now, I already know the name of the object I want, but you may not, and that's okay. I want a metro. Now notice that when I start to type any letter, it starts giving me suggestions. Right? We can use that to go faster, but also maybe to discover things. I'm going to show you another thing that's really helpful in Max to help us discover objects, because there's a lot of objects. I'm going to go Metro, and I'm going to attach an argument to it. Now, many Max objects accept an argument after the name of the object. So notice I typed Metro, and now I'm going to put an interval for the metronome in milliseconds, and it accepts milliseconds. Let's do just 1,000 milliseconds. Notice the syntax here. I wrote the name of the object. It highlighted it for me to be in this specific color. And then this text is white colored on the theme I'm using, and that's because it's just an integer argument. Okay, click away. It's good to go. Now I need to connect these because they're just standalone objects that are not affecting one another. Not yet. So what I'm going to do is I'm going to connect the outlet of the toggle to the Metro. What does that do? It turns it on. It's going to turn on. You're not going to see it do anything. Why? Because it doesn't have an output to show us something happening. Okay, so turn that off. What if I connect the Metro? What does this say? This outlet says output ticks of metronome. Yeah, let's put that into this inlet that says cause indicator to flash, and for later to bang an output. Okay, so I'm going to connect it there. Right. Let's see if it works. I've locked my patcher. I'm going to click on the toggle. And it works. It lives. Hooray! So, our metronome object is working. Great. Now, let's talk about some of the other things that we can do with this Metro object. So, look here. This is, you know, this inlet is blue. In Max parlance, we describe the red as hot and the blue as cold inlets. And the thing to remember is that the red inlet, if you're sending a bang or a toggle, right, you're sending a 1 through the system, that hot inlet is going to send the bang through the system. The cold one is not. The cold one is going to affect something in the object, but not send a bang through. Why is that important? Well, we'll find out later. Now, this one reads, when I highlight it, when I scroll over it, it says set metronome time interval. That means I can plug some kind of object into that to set the interval externally. So what happens is, in Maxland, the original argument is honored, and if you send a new number, it's not going to update the text inside the object. It will update the argument, but you're not going to see the difference in the text. Let me demonstrate. So let's make a message. We'll go up here, message, M for message, pretty easy. And it makes this this little box with the round edges, with the border radius 20 pixels, right? So you don't have to memorize that. I'm being a web nerd. Okay, so maybe it's not 20 pixels, but you get the idea. You get the idea. So I'm gonna put a message in here. Let's think of a new time interval. No. How about 500 milliseconds? So I'm gonna put 500, just the integer. Okay. Now, this message is gonna go there. If this goes to plan, the metronome will begin operating as it did at 60 beats per minute. And when I click this guy with the patcher locked, it's going to update the argument. Yep. Twice as fast. Now, I don't have a way to set it back. Can you think about a way we could use a message box to change the argument back to 1,000? Make a new message that just says 1,000. Boom. plug it in. And then with the patcher locked, I'm going to click this one and update the argument. Okay, pretty basic, right? It's fundamental stuff. We're not doing this just to make a metronome. No, this is just building blocks. So, great. I hope that when you're watching this, we're starting to see how some of these objects are interacting with one another. So, I'm going to turn this off. Now, messages are all fine and good, but what if I want to adjust this in a different way? Let's introduce the integer box. So, I'm going to press I for integer. Where's integer up here? It's going to be under numbers. And we have these different objects. Don't worry just yet about floats or this number tilde business. So we'll talk about that later at another lecture. But number, and the I is for integer, that's the one you want. You can just press I on your keyboard and it'll make one. So this one, I can interact with this one if I lock the patcher and then click and drag on it. I can also, after I've clicked on it, notice the little arrow is lit up, I can enter a number. Right? So let's see how interactive this can be, right? So I'll put maybe like right there. Now, when the number changes, it's going to send a bang. It's going to send something updated to that. But remember that because it's a cold inlet, it's not sending a bang through to the bang object. It's just updating the argument. But it needs something to say go to do that. And the thing saying go is the number changing. So I can increase this. And if you're watching the little bleep bleep here, it is slowing down because the interval is getting the intervallic number is getting higher and the interval is getting longer between bleep bleeps right here. And if I drag it down, it's going to become faster. Okay, so that's an integer box. Now you can also send messages to integer boxes if you wanted to. Let's see this one. This one says set displayed number and repeat to output. So it would be possible for me to chain a message that says 100, not 100, I don't know, let's do 1200, to this, lock the patcher, hit it, and it updates. Okay, if you wanted to, right? When do you use an integer object? Well, I use them when I want to update the number kind of to my taste. But I can also kind of use it dynamically in a system where, let's say I have random numbers. Now, if you downloaded the patch on the website, on the class website, and on Canvas, you'll notice I added something that wasn't in our original lecture class. I added a random object. Let me just give you an example of why this would be hip. So I'm going to create a new object that's called random. And random, we're not going to worry about the seed argument. We're just going to use the range argument for right now. And let's generate random numbers. I don't know. Let's go up to, sure. Where is my mind? Not 20,000. Did I know that one? No, let's go to 5,000. Okay, sure. So now let's test this on its own. And what I'm doing here is I made a random object. I gave it a range, which is basically, going to be 0 to 4,999. And I'm going to have it make a number every time I press this bang. Okay, so let's connect this integer to that integer. It's a long one. Some of these, when they get too quick, that was funny. That one acted a little funny when it was under 1,000. How interesting. Anyway. It's an unexpected anomaly. But this is the idea. And again, you can control the random number range here. So wait a minute. Is it possible to set up another random number generator to your random number generator? Yes. Yes, it is. It totally is. Even then, notice how I had to click on this bang. Well, what if I connect it here? So every time, wait a minute, every time the metronome sends an impulse, it's also asking for a random number that basically is the duration we have to wait for another click. Okay, wait a minute. Just want to point out, we've created a device that's handling time in kind of an unexpected way that basically, how do I say this? We can't predict. It's a little Markovian. We can't predict what the next interval of time would be. And that interval of time is affecting how long we have to wait for the next interval. We're not even dealing with sound yet. We're just playing around with time, right? So this is what's so neat about Max. It invites us to think in different ways about systems and about time and about how some of these things are interacting. Okay, let's, I'm gonna get rid of some of these cables. To do that, I unlock the patcher, I click on the cable, it highlights, and I hit delete. Boom, gone. No problem. You can also click, select, drag, and it's gone, right? Okay. So we're gonna move this guy out of the way there, because we're gonna use it again later. Let's make some noises. Here's your reminder about MIDI. And we're still thinking in MIDI 1.0 right now. MIDI 2.0 exists in some places, and there's a lot of backwards compatibility with devices. For right now, for the fundamentals, we're going to deal with MIDI 1.0. So as I was saying in class, MIDI messages are essentially 8-bit, but one of those bits is reserved for system messages. So basically you have 7 bits to represent velocity and pitch data. Well, how many integers are available if you have 7 bits? And remember, we're talking about a 1 or a 0. So you have like 7 slots, and each one of them can have a 1 or a 0. I'll give you the answer. It's 128. How would you do that? Well, because we're dealing with a binary system of zeros or ones, right? Because there's only 2 options, 0 or 1. What you do is 2 to the power of however many bits you have. So 2 to the power of 7 is 128. Now that has consequences for us, because that means that we have 128 pitches available, and that also means that velocity is represented with 128 integers. I asked this question in class a while ago. If we think about our notation software and the way that oftentimes we approach scores and performance as classical, jazz musicians, rock musicians, etc., we tend to think about dynamics in terms of, well, what, maybe 6, 7 or 8 like gradations of volume. I mean, okay, like pianissimo, piano, mezzo piano, mezzo forte, forte fortissimo, and you could keep adding Fs or adding Ps, but at a certain point, maybe we don't feel a great difference between 4 Ps and 6 Ps. Maybe at that point, composers are using it also kind of as a color or a feeling of intensity or drive. That's a topic for another day. Anyway, so compare that. Now, that might seem like a good deal. Oh man, well, my classical music system seems to have, six levels of dynamic response, and my MIDI's got 128. How many do you have as a human being? Now, I'm asking that because oftentimes we don't quantify this. We allow the notation or the software or whatever we're using to determine for us what the volume level is. But if we were being very, very particular and detailed and zooming in close on what we can do with our instruments, whether it's with our hands, with air, etc., I'm sure that we could start to argue that maybe 128 is not enough to fully show the nuance of human performance. Well, that's something for you to think about. I'm going to let you think about that. Now, back to Max. What does any of this mean? So let's do this. If you were in class, I'm sure you remember we had a lot of fun with a total cacophony of held notes. I'm going to demonstrate what I mean. We're going to make an object called note out. By the way, if I type something wrong and hit enter, it'll turn like this sandy color. That's Max telling me that that's not a thing. It doesn't recognize it. So if that happens to you, just be aware that it's not recognizing it. You don't have to delete the object. You just type it correctly, and there it is. Okay. So this is my note out object. This is what we're going to use to send a MIDI note basically out of our computer. So right now I have my little Mac speakers as my main my sound output. Now let's look at the note out, what it accepts. Notice it has no outlets. It only has inlets. That's because the thing it's doing, I guess we could call it terminal in this sense, in that like the signal is stopping there and it's becoming something else that is being handled by the computer. Think about it that way. So we have pitch, velocity, and MIDI channel. We're not going to use the MIDI channel right now. We're going to use pitch and velocity. Now, pitch just says pitch. Here, velocity, this is important. Velocity, 0 for note off. And we'll see why in a second. So, let me see here. Let's choose a pitch. Ba 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 60. In our MIDI system, 60 is middle C. 60 is middle C. So that'd be C4. So C5, right, would be 72, right? And then it would keep going up from there, right? Or then like 48 would be C3, etc. On our keyboard. And we'll talk about that more next time I see you in class anyway, just to recap that. So this is my pitch information, and I lock the patcher and I send it, and I'm clicking on it, so it should be sending a signal through, right? I should be sending a bang. It doesn't send anything. Well, because I need to set a velocity. So let's do 100. And we're going to put that there. Luckily for us, note out will store a velocity we put in as 100. It stores it. So I just click it once, and then I can sit here and make sound, make some MIDI sound with just this 60 interval. So that's cool. Great. Well, let's add some other ones, right? I don't know. 62. What we did in class was we made a scale. So thinking at home, what would the numbers be for a C major scale? Now we got to think about whole steps and half steps. In major scale construction, I'm going to put a little comment box to help us. That I press C to make a comment box, and I'm just going to type into it. It's not really an object, not really. I'm going to remind us whole half are our steps for a major scale. And because we're dealing with semitones right here, right? Well, 60 to 62 is our whole step. The next number would therefore be 64. The next number would therefore be half step 65. Right on. I'm going to get this out of the way. Next number, 67. Oops. Okay, next number. Yep. 69. Next number. Quick, 71. And then 72 for our last half step from 71 and 72. I'm going to plug each one of these in to the note out pitch. And let's see. There it is. Hey, do you hear those notes kind of hanging on? It's like someone's holding the pedal down. Interesting. Okay, so there's that so far. Okay. I hope that when you're watching this, you're already thinking, what if I hooked this up to that thing? Right? You could basically automate a piece using this unconventional way of thinking about it. Okay, cool. Nice. Cool story. Let's get into trouble. I'm going to make an object looking ahead, a message that's just 0, and set it into velocity. And let's see. It's not going to clear the one that already sounded. Let me see here. Nope, it's not going to clear the one that already sounded, just all the subsequent ones after it. So let's get into trouble. Here, let's do this. I'm going to make a new object called PGM out. Again, this is kind of a terminal object, if you will, where we just have 2 inlets and then no outlets. What I'm going to do now is I'm going to plug in an integer to the PGM out. Boom. Boom. There it is. Now, what this is doing is this is saying program out. If I change the number here, we're going to get a different sound. Oh no. Oh no. Do you hear it hanging on? This is a fundamental affordance, if you will, of MIDI, is that it demands a note off command. If I hit 100 and then hit an E64, it's going to do this like until the computer dies. It'll just sit here forever and ever, right? Not forever, but you know, yes, as long as our physical universe is still consistent. So, great. How do I stop it? I set the velocity to 0 and click it again, which effectively is sending another message, a note off message, to that pitch that was ringing. But you might be saying to yourself, hold on, Dr. Welty. My keyboard doesn't do that. And I'd say, yeah, no. That's because these devices oftentimes are sending a note off message when the key is lifted, if the thing is sustaining. Now, with our piano, remember, let's go back to 0, which is our piano patch here. Boom. And then set the velocity. Well, it does have a point where the sound is gone. Technically, inside the computer, that sound is still going. That it's still playing, but right. But the sample itself kind of ended anyway. But when I went to a synthesizer, or no, that one. Aha! Here's an organ, like a B3 sound, right? So that one's gonna keep going forever until I turn it off. That's worth knowing in MIDI. Now listen, if you're playing around with Macs and the MIDI just won't stop, and you can't stop it, and it won't stop. Then what you gotta do is you gotta just close Max and then relaunch it. I hope you saved your work, right? Otherwise you'll go crazy with the sound. Wouldn't it be great if someone made an object that automatically sent a note off message? Well, guess what? There is one, and it's called Make Note. Let's investigate Make Note. Now, by the way, I haven't showed you this. I'm going to show you this right now because this is useful now. So, with any object that exists in here, we can right-click it, or I'm using my laptop, and so I'm touchpad. I'm using 2 fingers, and I can hit Open Help, and it's going to open a new patch window, and it's going to give me basically a little tutorial that I can play around with. Let's see what this one does. And it's locked, so I can use it. It's going to be the same rules. Nice. Set it to 10. Oops, I didn't want that. And there's more stuff. The stuff gets a little wild, so don't worry about that just now. Anyway, so you can do that for any object. Any object has it. Even buttons. Okay? Cool. So let's hook up the Make Note. Let's go back. Wait a minute. Let's go to Make Note. Open Make Note Help. And let's look at how they set this up. Remember that organ sound would keep going forever when I just plugged it into Note Out. But now I have an Make Note as an intermediary object. And if you look carefully, watch down here. I'm going to hit another button. I want you to watch these boxes right here. So, hey, you see that? Velocity was 60. And it stopped. I didn't do anything. It stopped automatically. Because there was a durational argument here for 1,000 milliseconds, which can be changed, right? But the basic argument was 1,000. It also has these little messages that we can send into it. Notice they're in the first inlet. Cancel future note offs and send all note offs out now. It's kind of a failsafe, right? There's more stuff. Hey, cool. Okay. Hey, look, this is using our random number generators, isn't it? Yeah, right on. We'll talk about this at a future lecture. Maybe next lecture I see you. Not today. Repeat modes. There's even more stuff. Hooray! You can investigate on your own. We don't need to be that in-depth about it. So, pardon me while I check my phone. Okay, just keep an eye on the time. Here, I'll have to edit that out. Anyway, I'm going back here to my Max patch. And Note Out needs to be after Make Note, because Make Note is not making the sound. It's the Note Out, right? That's handling our MIDI message. So what I'm going to do is I'm going to PS pro tip. I'm looking at the the school keyboards have it too. They have an option key. You can hold Option and then drag and select a whole bunch of cables like that. What I did was Option, hold it, click, drag, select all the cables, boom, and I can just get rid of them that way. Pro tip. Anyway, Make Note goes here. No arguments yet. Let's make sure we have it plugged in correctly. This is super important. This is super important. I hope that you're making this patch along with me. I hope you're also doing this with me. If you're doing that, be sure that you are routing the cables, the virtual cables, the same way that I am. Because if you don't, it ain't going to sound. Check it out. Make note, pitch output. Can you guess where that one's going to go? The one that says pitch. Boom. Click and drag. This one says velocity output. Cool. Click and drag. Velocity. Yep. MIDI channel, we're not going to worry about that just yet. Now, let's go back here into the make note and set an argument. I don't want to do this. Nope. Hang on. I want to do it this way. I'm going to do it like the patch set it up. I think it's going to be a better way and more interesting for us. So let's create, these are going to be our pitches up here. But let's create an integer, I for integer, plug it into velocity. And then lock the patch. Let's put it at 94, whatever, right? And then let's do the same thing. Let's make an integer box that's going to go to duration. Now this is again in milliseconds. So, got the burps. So, I go here, and I'm going to set it at some milliseconds. Remember, just like we did this one. That means that after 954 milliseconds, it will send a velocity 0 to note out. I know that seems kind of strange. I'm making these faces because, think about it. We're not so much saying turn the note off. We're saying replace it with the same note, but its velocity is 0. It's a subtle difference. But in electronic and computer music, that's how MIDI transmission is working. Right? So when we say note off, we're basically saying send a 0 in the velocity, however the velocity is being handled. Like in Max, it's being handled through a box here. So, okay. Anyway, I want to do. No, this will be fine. Let's plug it in. Plug in. Let's do this one and see if it works. Let's test it. Let's lower the duration. Remember, it's updating the duration as I'm changing the number. It's sending bangs, updating it. Okay, let's see if the, remember 127 is our ceiling. Why 127? Didn't you say the 128, Dr. Welty? Are you taking away one of those integers? No. 128, yes. Remember when I was talking about the random number at 5,000 was actually going to read 494999? Well, that's because these things are 0 indexed. That means that 0 is the first number. Right? Yes, 0 is the first number. So, that means that you basically have 0 to 127. That's still 128 integers, but that's how computer land works. So, cool, it works. Let's hook it up. Hook it up, hook it up, hook it up. I need more coffee. Good thing I have this. Oh. It's been sitting. A little skunky. Okay. All right. Let's change a different patch. Yeah, that's like electric guitar. Sounds exactly like an electric guitar, right? So, that is some fundamentals of MIDI. Now, how would I turn this into a device that can now make a sequence? Remember in our class, we were talking about sequencers, What is a sequencer? Well, it's going to do things in a sequence, right? Okay, cool. So many of you have probably used sequencers like on drum machines where you have like a row of buttons that light up, right? And they're going in order and you're turning things on or off with that idea. You know, it can also be like a grid of buttons and they're being read across. There's a number of ways that we're going to do this in Max. I'm going to show you in this video, this lecture video, the way we did it in class, which is only one of several ways. I'm going to make another video in preparation for our class on Tuesday that will talk about some of these other methods. I'm still going to talk about those methods in our lecture. I would encourage you to take a look at that video before Tuesday, like Monday, just to kind of prime yourself for some of these different objects and how they're behaving. So check it out. Let's go back to our metronome. I'm forgetting what the last argument was in here. Let's just set it back to 1,000. Okay, we're back to 60 BPM. So, well, let's think for a second. Here's the problem. What I want to do is I want to send this bang into each one of these messages. So I'm going to connect the bang to 60. Okay, great. What if I connect the bang to 62? Okay, I kind of like that. But that's not what I want. I want them actually to play in a sequence. But if I hook them up, they're just going to all play at once. Are you seeing the problem? I hope you're seeing the question. The question in my mind is, okay, how do I get this to bang and then send these in sequence in some kind of order? Well, there's objects for that to help us. Kind of, sort of. So we're going to make an object called counter. And all counter is doing is it's just keeping count, right? That's all it's doing, keeping count. So I move the counter down here. Let's try it out. Let's understand what's going on here. So let's look at the arguments. I'm getting ahead of myself a little bit. Counter, hit space, arguments, options, int. Yes. When we put the int on here, well, this isn't telling us a lot. Let's go to the help document. Let's go look at the help document. Okay. So this is the one with no arguments. They put a comment that says no arguments counts upward from 0. So it's just going to go indefinitely. Is that going to solve our problem? No, because after we exceed integer 7, then there's no more. It's just going to keep going. Blast. Okay, so what about this one? This one has 2 arguments, 1 and a 4. Let's see what happens. So I click it, 1, 2, 3, 4. This is saying start at 1 and then go to 4. And then after you're done with 4, loops forward back to 1. Okay, it's like visual Einstein on the beach. Loop backwards. That's right. It can even count down. Now the thing that's happening here in the arguments, check it out. In the arguments, if there's just 2 integers and no other one, like no third one, it's assumed to be a 0, and that means just operate normally. Count forwards and then loop back. If it's a 1, this is telling this first argument it's not count from 1. This is saying count down. And when it's 2, it's going to be a palindrome. Let's check it out. Aha! It counts up and then back down. Neat. Like a palindrome, right? It's the same forwards as it is backwards. Yep. So, yeah, there's other options we can do. I'm not worried about that right now. There's more details which you can explore, ways to set these things dynamically in real time. Fun. A more thorough explanation, like I said, of these things. So let's ask ourselves, what do we need here? Well, we need 8 outputs. We won't zero index it. Just go 1, 8. Let's see if this works. Now, I'm not going to connect a message to this. I'm going to connect an integer because I want it to be actively updated. So counter, current count, connect to the integer. Now, let's hook up the flashing light to thing to be counted. It says that, I promise. It works. Hooray! Okay. Now something is keeping count, because it wasn't doing that before. This thing is actually keeping count. Now, how do we tell it? When you have a 4, do this one versus a 6. How would it know? There's an object we're going to use called select. Now, select, for every argument we put in, it's listening for that input. So 1, 2, 3, 4, 5, 6, 7, 8. Why? Because those are the ones we're counting. Okay, I hooked that up there. Great. Now, what the heck? Take a look here. The outlets for select say bang if input matches 1. Bang if input matches 2. Okay, I made 8 of them because I got 8 pitches up here. Okay, so what I'm going to do, this is going to look a little convoluted, but stay with me. So I'm going to connect each one of these. Boom, that's 1. This one is 2. This one is 3. This one is 4. Ah, it's already working. It lives. We have created life. You can impress your friends. You made a major scale. And to stop it, I just hit that button. I'm going to take a quick pause really fast because I need to check something outside. And now I'm going to resume the next part of this video. So you can pause here and take an intermission because I am going to take an intermission. So hope I see you again shortly because we're going to talk about more of this stuff. All right, and we're back. So where we left off was just talking about some of these simple features with MIDI in Max and ways to program that. Now, I'm sure you would probably want to make things a bit more interesting. And this is thinking toward the assignment that I'll be due on Friday. Because what I've asked you to do is to basically create a piece using sequencers of some kind of your own construction in Max. In class, we're going to talk about some other methods, and in that video I mentioned, kind of a sneak preview of things we're going to talk about in class. But let's think about this. How would I turn this into something that's interesting? Well, we're not trying to recreate, Symphony No. 5 or Borodin, Polivetzian dances. We're not trying to recreate any specific older piece. We're doing this in an experimental nature to see what comes up. So, what if I do this to start? And this leads me actually to a it disappeared. This leads me to another point about MIDI and about Max. So let's, I'm going to zoom out a little bit. Get rid of these guys. So what if I just select all of this and then hit Command D? That's Command, the letter D, to duplicate. It's going to look like a mess. Don't click away because everything's still selected, right? Click on something and then drag it. Look, we have a clone. An exact carbon copy of what we had. But let me tell you that that's not altogether too useful just yet because, well, these are all still on the same MIDI channel. What's a MIDI channel? Well, think about it like as if it was a channel, it was like a station on the radio, or it was a channel on the television. It is more or less a pathway to transmit information. And in MIDI's case, it can transmit up and down and, sending and chaining things, which we'll talk about later. But you have 16 channels available. And that's a MIDI 1.0 standard, and that's still the standard in Macs. What that means is you have, 16 places, lanes, so to speak, maybe. Think about it with lanes, where you could transmit information. Okay, well, how would you change the channel on here? So, it's pretty simple. What we're going to do in this first one is we're going to say note out argument 1. And that's going to be the required integer. When I didn't have one, it was just the first one. Now I'm declaring it. I'm going to go change this because what I didn't tell you is that PGM out needs 1. Those are linked now. They were already linked before. I know. Okay, they're already linked. Now let's go down here and, oops, never mind that. Let's change this to 2. Argument 2. This is channel 2. Now, I can run them concurrently, and they're not going to step on each other's toes because they're 2 different channels. Now, one more thing I want to say. This is kind of a critical question here. How would I get both of these toggles to turn on at the same time? What's that? Oh, I could use a bang, or I could use another toggle. So let's use it with another toggle. So I make a toggle here. I make a toggle here, and I'm going to plug it into both of these. This will start both of my devices at the same time. I want them to start at the same time. I need to give this one a velocity, right? It needs not that high. Wow. Make this one a little quieter than the other one. Velocity, and we'll make this quieter but longer in terms of its duration. How about that? And let's see what happens. So if they sound out of sync, it's because the counters, I accidentally clicked that toggle a second ago. Let me reset these. How do we reset a counter? Right here, this one. Resets counter to number immediately. So I'm going to make a message that just says 0, and I'm going to make that it's going to reset. See what I'm doing? I'm sending both of them back to 0 by sending that message. Okay, cool. I'm going to put this up here because this is kind of like a control, right? This is like an essential control. And I'm going to put a little comment here. Reset. Great. Now, it's reset. Now they won't harmonize. Okay, absolutely basic, very fundamental. Now these MIDI sounds, these are the Apple MIDI sounds. This MIDI data is being sent to the MIDI chip in my computer, and it's making that sound. Are they the greatest sounds in the world? Not a chance. But they exist, and we're using them for our purposes right now, just to practice with MIDI. Don't worry, later on, as I demonstrated in class that one day, we're going to use this information to control an external synthesizer that's going to be a bit more interesting than just these sounds. So bear with me. These sounds are what they are, right? Okay, so let me go back over here. The thing I said this in class, when the major electronic musical devices, those manufacturers got together and developed MIDI in the 80s, one of the things they decided on was to dedicate channel 10 to percussion sounds. And that's still true. So if you go here and you say, let's change this to channel 10. I don't even have to fool with this because these are now percussion sounds. Neat. So wait a minute. Do you mean to say, Dr. Welty, that you could duplicate this thing, 14 more times? Make a wild 16-channel MIDI extravaganza? Why, yes, you could. And right now, we're only dealing with 8-step sequencers, right? There's 8 steps right here. 1, 2, 3, 4, 5, 6, 7, 8. 8 steps. But you could make them 16. A lot of sequencers, if they're hardware sequencers, they will have maybe just maybe sometimes a row of 8 or a row of 16. But the way you can like toggle between things, they actually have more steps that are visible with other buttons. Like you're seeing like 8 or 16 at a time, and maybe there's actually 32 or 64 steps. It's a thing. Anyway, we can freely make more steps using this method with a counter and a select. Now, I want to talk about a way that you can kind of play with this some more. Remember we were talking about those random buttons? Well, I could create a random, and let's use the range 128. And we could send this information into one of these. Now, here, this is more of a finer point here. This is a finer point. You can change the output of a message box by sending some kind of number into the correct inlet. And message boxes are a little weird. So I'm going to show you 2 ways to think about this. I'm going to plug this in random. I'm going to put an integer right here so we can see it. We can see it happening. And now I'm going to do this. And let's see if it behaves as expected. Well, it's behaving how I expected it. It's not sending that data through. That's because of the way message boxes work. So this one, trigger the message, set changes it. Let's do this. The cold inlet says, set the message without output. That's right. Now we're transmitting that integer to that message box. Pretty nifty. That way, you don't have to turn these all into integers if you don't want to. You can just make them different message boxes. Okay, cool. You can use that to randomize some of these things. Now, for now, if you want to send multiple random pieces of information, it's ideal to create a few random boxes or to delay a series of bangs going through them. Now, be aware of this. that if you were to do this and then plug them all, remember how we were plugging into the cold inlet to change them? Check this out. They're all going to change to the same one. That's because it's the same random number generator, same algorithm in this object, and it's producing the same output that's going in 3 places. Okay. So then what are some ways that we could send a series of random numbers for each one? Well, one way to do that is that we could just create another random and then activate that one. So this one goes there, and then this one goes to number 2. That's possible. Aha, now the numbers are different. See what I'm saying? We could do that. That's a possibility. We could also we could do a similar thing where we're actually sending out another series of counters like we did here. It's a little bit of a pain, but it's a possibility. In our class, we'll talk about some other ways to send random numbers that I'm thinking about it, and it's too much for this video for right now. But anyway, you see where I'm going with this. You could start to randomize the sounds. You could randomize the metronome timing. You know, if I go here and I make this at half speed, set to 500, boom. I'm sorry, I said half, double speed, half integer, but yes. It starts to get a little more interesting than just bop, bop, bop. So again, we're creating something that's a little experimental and a little strange. Yeah, for sure. I encourage you to experiment with this. I hope you're enjoying your break, but if you get a chance, play around. I'm gonna put this patch, which is very similar to the one in class. I'm gonna put this one up on the internet too, so you can play with this one and experiment with it and change some of the numbers around and mess around with some of those things. We'll have more to add to this process when I see you again in class. Anyway, that's all I have to say for right now. And I hope this seemed interesting. The sounds are a little funny, but we're going to see cooler applications for this kind of MIDI routing pretty shortly. Anyway, have a good rest of your break. If you're seeing this after the break, I hope you had a good break. And I'll see you in class on Tuesday. All right. See you then.